In this video, we will talk about pgModeler, the modeling tool for PostgreSQL, and more specifically about the path inference feature of the Query Builder plugin. The path inference engine is a solver for SQL joins. What are its goals? Well, first, speed. It helps making stupid queries fast. And second goal, discovery of a model. It can help you find your own path in a maze of relations. The process is pretty easy to explain. You have tables that you want to join in SQL, and you get as output a join sequence. This solver feature is a small part of the research field called Natural Language Interface for databases. The target is to extract data in the most human-friendly way possible. NLIDB consists of a lot of very complex subfields: speech-to-text, natural language processing. Here we restrict to a simple subset, and in this subset, path inference is a missing piece between existing features, the object finder, and code execution. Well, there has been a decent amount of research on this topic. There are a few links in the README, but this is a primer in free software. Here is the user experience with the feature and how it relates to NLIDB. You search entities with the object finder. You insert them in the Query Builder input panel. The path inference engine computes and returns a ranking of valid paths. You select one path, and then you execute the produced query as seen in the core plugin video. We'll now look at how the solver works and how to use it. So let's talk a bit about the inner workings of the inference engine. A few words about graphs. You already have, in relational databases, graphs almost ready to go, with tables as vertices and foreign keys as edges. Who needs graph databases to use graph algorithms, right? This is a sneak peek at the implementation. If you are not familiar with graph theory, here is what you can remember. The main graph problems addressed here are the shortest path problem and the construction of Steiner trees, and the algorithms used are Dijkstra and Dreyfus-Wagner. The workflow of the path inference engine itself. You start with the database model, obviously, and the tables that you inserted in the Query Builder panel. Then, from right to left, you set up the solver parameters. This part is for modulating the search space, and this one is about edge weights. You then hit the Run button. It displays a report tab while running, and you can stop the solver at any moment if space or time complexities have gone through the roof. When the run is successful, the ranking of valid paths is displayed in the Output tab. After you have chosen your path, you hit the Set Path button and you have the code ready. When there are only two tables to join, the algorithm will resort to Dijkstra only. In this simple example, provided you expand the search space, like this, and run, the solver returns the three paths from shortest to longest. With three or more tables as input, Dreyfus-Wagner comes into play, like in this example. For educational purposes, you can also combine the Progress tab with a rendering of the run directly onto the model, and hopefully get a feel for how the solver works. I will let the solver sort of explain itself. First, in green Steiner points, second, in orange and yellow shortest paths, and third, step 1 times step 2. In this example, we have 4 distinct Steiner trees and 4 shortest path variants, so we get a list of 16 paths. Lastly, with complex models, such as the next one, you can easily get lost in hundreds of results. You might want to set up functional states, that is, subsets of the model split apart visually, and run the solver only on those subsets. Here is the preview of the multidimensional layers feature, which is likely to appear in pgModeler's 9.3 development cycle, and it does just that. That's it for this video. Hope this can help you in your database tasks. You can find the installation instructions or the plugin in the README, and there's an arm-long list of limitations and targeted enhancement in the contributing section, so feel free to lend a hand. Thank you. See you next time.